Hello, young people. Today we are going to talk a little bit about scientific method. This is not our focus for today, but we're beginning this process of doing scientific method. Now, some have fewer steps, but generally speaking, we all agree that we need to ask questions, make observations, do some research so you can form a hypothesis, design an experiment, collect data by doing the experiment, analyze the data, form conclusions, and write a report. That's generally speaking the scientific method in its whole, and it's just a problem-solving method in all honesty. It just helps us make sure that we're all kind of doing the same thing. But our focus today is going to be on this idea of observations. So we need to think about observations in terms of what they are. So we want to talk a little bit more about observations and inferences and the differences between those two. So observations are things that we do using our five senses: smell, sight, touch, hearing, and tasting. Now, in chemistry, we have to be really careful about the tasting. Unless you're told to taste something, do not taste anything. Do not put anything in your mouth from the chemistry lab unless you're told to do so. And in those cases, it would be safe. But do not do any tasting unless you're absolutely told to do so. So we're going to be relying mostly on our smell, our sight, our touch, and our hearing. Um, every once in a while, every great once in a while, we'll be using taste. But you have to use these senses, and you're taking in information from the world around you with your senses. And those strictly are observations. So when we think about observations, we can have observations that are qualitative. This has the word quality in it. They're observations of the quality of things. Things like color, the taste of it, how does it feel, how does it smell. It's describing quality. So if we look at the fireworks, we can see that they're different colors. We can see that they might be different shapes. The ones that we're seeing in the picture just look different colors. We can see in an apple, there are different colored apples. The skin is different. Some skins are bumpier, some skins are smoother, some skins are shinier. We can smell it. You can smell the fireworks if you're close enough. So all of those things are qualitative. Anything that tells us about the quality of what we're observing is qualitative. The next one is quantitative, and quantitative has the word quantity in it. And this implies that we need a number. So we're going to have to use tools to measure to get a quantitative observation. Our most common tools for us are rulers, graduated cylinders, balances, thermometers. Those kinds of things we use for quantitative measurements. We don't typically use beakers and Erlenmeyer flasks because they don't give us reliable measurement. Now, if we want to approximate, those are good. If we need a reliable, accurate, quantitative measurement, we're not going to use those things for that. The observation has to be counted or measured, and it must include a number and a unit. Units are going to be super important in chemistry. You cannot have a quantitative observation without a unit in this class. And so that's going to be super important. And in chemistry, quantitative observations are king. Qualitative observations are good. Whereas in biology, qualitative observations are great. But in chemistry, quantitative observations are better. We want to do analysis. We want to have some analytical understanding. And so that's where chemistry is very different from the science of biology. Now, inferences, on the other hand, are explaining the observations that we made using prior knowledge or past experiences, and we draw a conclusion about the observation made. We're adding to it. We're not just saying what we're seeing, what we're smelling, what we're hearing, what we're feeling. We're saying more. We're adding more information to the problem here. So let's look at some options here that we can see. So if we look at this picture here, we can definitely make some observations here. We definitely see a tree on a house. We definitely see the tree roots uprooted. Those are all observations. We can see that the tree is still green, so this is probably in the summer and it's got full leaves. So we're probably talking, mid to late summer sometime. we're looking at the ground. The soil is very dark. And we can also see that it's definitely not up anymore, right? All of those things are observations. But when we start to think about, oh, the ground is wet, that's not an observation. We don't see any sign of water anywhere here on the ground. All we see is that a tree has been overturned. The soil is dark. That's all we see. So to say that it's wet, that is added information that we added from prior knowledge. To say this happened in Hurricane Fiona, we don't know that. We just know that a tree fell down. We don't know why. We don't know what caused it. All we can do for observations is to observe the different factualities. Everything else that we add to it is a conclusion or an inference. Okay, let's look at another one. All right, so here I see sand. I see a rusty tire and it looks like a wheelbase. So the tire is rusty, the wheel is rusty. And then I see a tire that looks very chewed up because I see all of the white strings all over the tire. So I know that this particular tire is probably not ever going to be used again. It's damaged to the point of no return. And I can say that because I have some knowledge, but that's not an observation. That's adding knowledge to it. So I can say it's in sand. I can say I see rust on the wheel. I can say I see the white strings from the tire fabric. I can say I see a hole in the tire on the right side, and also it looks like on the left there's a smaller one. But the moment I say something like, this has to be in the desert, I don't know that it's in the desert. I know it's in the sand. The moment I say that this truck is old and probably hasn't been used in a while, again, that's information I'm adding to what I've seen and what I've observed. So be really careful because when we are taking observations, we want to make sure that we're not adding any information to it at that point. We will be adding information later after we've looked at it, after we've researched it, after we've tried to figure out what we might want to test, because then we're going to make some inferences about what's going on. So be really careful about that. Next, here I have a house and it looks like it has a waterfall as part of it. I don't know what's going on, if this house fell into this place, if it was built there, I don't know. All I can say is this. There's definitely water underneath some of those patios. There's definitely water coming down the stream. I can see that. I can also see that the leaves are orange, red, yellow colored. I can see that the building is made of brick in some places. I can see the brick of looks like the fireplace or the window here. And I can't see much else of the house. Now, I can make a lot of assumptions here, a lot of inferences. This house fell into this creek and is inhabitable. I could say this house was built like this. I could say it must be fall wherever this is. Now, all of those are inferences. I'm adding more information to the object here. So make sure you're thinking about this. Be careful not to add information from prior knowledge to add to your ideas here. Thank you very much.